Hi everyone, and welcome to week 14. In this week we're going to see how reasoning works with the quantifiers we introduced last week. We're going to start off with universal elimination, sometimes called universal instantiation. The basic idea is just that if you have a universal claim about things in your domain, you can introduce a constant that names one of those things and apply that universal claim to the constant. So if you say everything is an object, pick an object, say C, well then C is an object. We'll see how this works. Universal elimination is one of the easiest rules for the quantifiers, and it's a way of thinking that we're used to because we use it all the time. What this allows us to do is to go from a universal statement like everything is S, where we have this universal sign everything, and derive a particular statement affirming S of a constant. So C is S, and that's particular. The reason this works is because our domain is non-empty, as we already stipulated, so when we say everything, we're at least talking about something, and because our constants, like C, have to name something, so we know that they name some object in the domain. Here's an example of this kind of reasoning in action. Suppose we say everything is real, so we have this predicate real. Well, from this we can go on to say that for any object in the domain, suppose our domain is just the universe, naming an object in the domain, Alaska is real. And this is a statement about a particular item named by a constant, or a name here, Alaska. To give a slightly more artificial example using the blocks language, we could say everything is a cube in some world, and this is universal, and therefore A is a cube. And that's the key to universal elimination, sometimes called instantiation, and that's the first of our rules for reasoning with quantifiers.